Hi everybody, going to broadcast the solutions to homework 1.6, A1, and B1 and 2. So again, these are taken directly, taken directly off old free response number 4s. Here is A1. So we have a solution of sodium hydroxide. So I'm going to write that as Na plus OH minus is added to a solution of lead 2 nitrate, Pb2 plus, NO3 minus. So I look at this and I see only ions. I do not see neutral atoms. So I'm going to do my swap, and there is my stick. So I'm going to rewrite the ions. Remember, nitrates are always soluble in water, and this one is going to get stuck together as the precipitate. Swap stick, and I'm going to cancel out my spectator ions. There they are. And I'm going to rewrite it in the correct format. I'm going to do that up here. 2OH minus plus Pb 2 plus goes to PbOH2. That is the correct answer. I do challenge you guys to do this if you want. We're going to talk about it later when we have a review of stoichiometry. Not necessary right now. Okay, going to this next one. Okay, this says excess nitric acid is added to solid calcium carbonate. So I want you really to look at this closely here. We do not see any water words. No water words. And because there are no water words, we're going to get no ions. Okay, so you got to really pay attention to this here. Nitric acid is formed when you have H plus with nitrate. However, we're not going to show any ions because there's not a water word. And solid calcium carbonate is what you get when you have calcium 2 plus with carbonate CO3 2 minus. But there's no water words, so we're going to have no ions. CO3, I'm sorry about that. Okay. Now we're still going to have a swap. Okay, we're still going to have a swap in this circumstance, but there's no ions initially. Okay, so you are going to have the swap between the H and the CO3 and the Ca and the NO3. So what we're going to have on this side is we're going to have Ca and 2 plus NO3, actually no, Ca, NO3, 2, and you have H with CO3. That's still going to do your H2 plus your CO2. So there were no ions because there were no water words. But the reaction still happened because H and CO3 still break up into H2O and CO2. So when you balance this, you're going to have to put a 2 in the front here to balance out the nitrates and the hydrogens. I'll briefly explain why statues made of calcium carbonate in urban areas are deteriorating. So simply acid rain, okay, actually is a lot of it is nitric acid. So it reacts with the calcium carbonate to produce H2O and CO2 gas. Okay. This eventually causes the marble to disintegrate. Okay, if the statue, imagine the statue initially. So I'm going to draw a little statue. Hi, statue. I don't know what this is. This is a statue of something crazy. It's got arms. I'd say it has arms. And the HNO3 is reacting with it, and the statue is made out of CaCO3, and it's producing water and CO2. You can imagine the statue starting to like bubble everywhere. You have all these CO2 bubbles everywhere. The statue is eventually starting to disintegrate and fall apart. So I'd like to go over this real quick from the top. This one was a really straightforward one, formation of a lead 2 hydroxide precipitate. This problem was really tricky because we saw no water words. And if we have no water words, we're going to have no ions. Okay? But we had an H2O plus CO2 stick happen. So there are actually no spectator ions in this case. No spectator ions. So that one is a little bit tricky. I'm going to be lenient on it when I grade that in case people didn't watch the podcast. Again, if you look at this drawing, it should explain why statues made out of calcium carbonate in urban areas are deteriorating. The nitric acid in the rain is reacting with the calcium carbonate to produce this carbon dioxide gas, which eventually causes the marble to disintegrate. Thanks a lot, guys. Take care.